Okay, so here we have an example where we have 4 functions graphed. 2 of them are logs, 2 of them are exponentials. They want us to match them up. Okay. Well, I would suggest that we just start taking them one at a time. I'll take 10 to the x, and I'm going to make a xy chart out of it. So plug in 0, my pretty plain method of just plugging in 0 and 1. 10 to the 0 power, what's 10 to the 0? Anything to the 0 power is 1. So over 0 up 1, yeah, that fits perfect. Okay, now let's go to 1. 10 to the 1. 10 to the 1 power is 10. So that's over 1 up 10. Which one looks like it has the point over 1 up 10? Well, it's going to be this one. It's not. It's beyond the range of the graph, but it's going to be this green one here. This one goes up really, really fast. Let's try next. Let's try e to the x. So this is e to the x. So put in 0. Y equals e to the 0. Anything to the 0 power, even e, is 1. So that's right here, same spot. Put in 1. E to the 1. Now what's e to the 1? Well, use your calculator. It'll tell you 2.718, blah, 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 blah. We'll just say 2.7. So over 1 up 2.7. That's right there, over 1 up 2.7. Perfect. That is indeed the red graph, isn't it? Whereas the green, you can see the green over 1, it's already up at 10. So at 1, it's already, it's going to be, way off my screen up at 10. So it's going up faster. 10 is bigger than E. Do you know that? E is 2.7. E is about 2.7. So 10 is bigger than that. So a bigger base means the green graph goes up faster. Okay, let's try the other 2. Next we'll do the ln graph. Let's do that one. All right, ln of x. So again, put in 0. Y is ln of 0. Your calculator will give you an error. What does that mean? That's where the vertical asymptote is. Remember, you can never put 0 inside of a log. That's where the vertical asymptote is. So that's true. They have a vertical asymptote at 0. So no new information there. Let's plug in 1. Natural log 1. If you do that in your calculator, you get a 0. So that's over 1 up 0. Well, they kind of both go through that point. Not a super big help. Let's plug in 2. ln 2. I'm going to use my calculator also. I don't know what that is off the top of my head. I'm getting 0.69, so I'll just say 0.7. So over 2, right, up 0.7. This is 1, 2. Over 2 up 0.7. Yeah, it looks like that point right there looks like the blue one perfectly, doesn't it? Right, over 2 up 0.7. Can't be the black one. The black one at over 2 is only up like half. So the black one remains. Let's do this one. Go up here. X, Y, log x. Put in 0. If you try that, again, you'll get, that's the vertical asymptote. Put in 1. Log 1, you'll get 0. No big surprise, over 1 up 0. Now let's put in 2. So y equals log 2. This is where we were betting it was like a half or maybe below it. Yeah, 0.3. I'm only getting 0.3. So that's this point right here. Over 2 up 0.3. Sure enough, that's the black one. It is not as high. So just by plugging in points, we can find out which graphs are which graphs, and we can see how things pan out. The bigger the base, like the green one has a base of 10, it's bigger than E, goes up faster, like that. And the log graphs both go up, but they're concave down, aren't they? All right.